Hey, what's up, everybody? This is page 401, and I'm going to maybe like add some highlights that I did, but I've already annotated and highlighted on this paper. So be ready, pause the video at any time when you get stuck, and be ready to resume it as you need to see what comes next. All right, page 401. Let's get into it. Properties of quadrilaterals. All right, move my face small and to the side. Here we go. Okay, so first of all, in our video today, make sure that you are highlighting. You can probably pause right here, but I'm going to try to preserve some of the material content. Highlight the habits of mind. That is what we need to do as mathematicians. Reason abstractly and quantitatively, construct viable arguments, and critique the reasoning of others. All right. Now, in a property of quadrilateral, we have the main basic definition of what a parallelogram is. Opposite sides are parallel. That is our definition of a parallelogram. But we could also say, is it true, and perhaps it is, that opposite sides of a parallelogram are congruent? If you look at page 420, you can see those markings on page 420 regarding the properties, the diagram construction of a parallelogram, right? Opposite angles, no, opposite sides are parallel, so that's the arrowheads. And then opposite sides are congruent, those are the spikes, okay? Probably want to actually keep that page marked because we'll come back to it from time to time. Now, in our work today, consider the parallelogram that's drawn. Like, how do we prove this? How do we prove this is true for all parallelograms? And in essence, why don't we do like a triangle proof? Consider the parallelogram PARG, P-A-R-G, with diagonals PR and AG intersecting at point M. All right? To prove both pairs of opposite sides of a parallelogram are congruent, we should look at pairs of matching triangles. So one of the triangles I tried to highlight in blue is this one, ARG, and its matching corresponding partner would be PGA, or PAG, I mean. And so that's what I'm trying to showcase there. There's an orange and another orange. And then in fact, if you just look at the other diagonal, PR diagonal, then PGR, this triangle, and RAP, that triangle, they could also be proven congruent. How do we do that? We use our cards. We use the triangle congruence theorems, specifically that we look for sides that match. We look for angles that they have in common. We look for things that we can prove in order to say, yes, we definitely know the sides are congruent. So in this case, I'm going to say, we know, this is actually supposed to be flipped, but I'll just read it out the way that it is. The parallel lines or sides of a triangle, right? The parallel sides of a parallelogram. This answer goes here, and this answer goes here. This works. How can you use the definition of a parallelogram? The fact that opposite sides are parallel. This works because parallel lines or sides of a parallelogram crossed by transversals create congruent angles. You know, when we did same side interior and alternate interior, same side exterior, but we don't really use that one. Those congruent statements, give me a minute, those congruent statements are useful for showing that angles are the same. Now, how can you, what do the triangles share in common? Okay, this works because the triangles share a common side, right? Take a look at what's underneath this diagram here. What's underneath these triangles, this PR, that's shared by two triangles. Or if you look at the other two pairs of triangles, we have AG, that means that orange to orange, those two triangles, they also share the same side. Now, because they share the same side and the sides are parallel, we can look for like alternate interior angles. We can look for same side on both triangles. And once we establish that there are actually three characteristics that both of those triangles have in common, we can write a proof. Let's actually write a proof to prove that opposite sides in parallelograms are equal. Here we go. Here's the whole thing, all right? Get that out of here. So given parallelogram PARG with diagonals PR and AG intersect at point M. Is that true? Is that true? We have a diagonal, we have intersecting at point M. Okay, that given statement is totally right. All right, no more wiggling. Here it is. Pause, freeze frame, write it out, but listen to my words as you come back to it. So our statement is that we have parallel sides. We have two pairs of parallel sides because that's what a parallelogram is. That means that we have these angles, and we can point to these angles like angle PRG and angle APR. We can point to those and say that they are equal or congruent because they're alternate interior angles. We can do the same thing with angle GPR and ARP. They are also alternate interior angles that are congruent. Both triangles, the ones that I'm focusing on. Like I'm specifically focusing on triangle PGR and triangle RAP. I could focus on the other one, but I'm going to focus on that one. And because they both have this line in common, PR and RP, I just switched the letters on purpose because the letters are switched up here in the name. But they are the same line, and so it's the reflexive property, which tells us that they are actually congruent. You know what? There it is. Angle and an angle and a side. And that side is specifically between the two angles. So the triangles are congruent because of angle, side, angle. And if the triangles are congruent, and I haven't yet talked about the sides, like side AR and side PG, well, if the triangles are congruent, then those corresponding sides are congruent. Corresponding parts of congruent triangles are congruent. Last of all, GR, that bottom line of the parallelogram, just look up at the image. And PA, those are also congruent because they are matching sides on congruent triangles. They are corresponding parts of congruent triangles, therefore they must be congruent. And that's the end of our proof, and that's the end of page 401. Thank you for watching this video. Yo, hello. Thank you for watching this video. Thank you for checking in on our learning about the properties of quadrilaterals. There's more to follow. Page 402 is next. Like, comment, and subscribe. We'll see you in the next video. Thanks. Bye.